So here's one that is useful on an almost everyday basis, maybe an exam question. The 24-hour cycle of radiation and temperature change. The radiation drives the temperature change most days. There are days where winds coming in will overwhelm the radiative effects on temperature change, but usually it's the radiation. Daily temperature change is a function of the balance between incoming shortwave and outgoing long-wave radiation. When incoming energy exceeds outgoing energy, temperature rises. Thus, daily highs are generally reached sometime after solar noon. Here's how it works. You think, well, shouldn't it be hottest right when the sun is giving out its maximum amount of solar radiation to the surface? In other words, when the surface is absorbing the most, when the sun is high in the sky? Yeah, it sounds kind of logical, and that's certainly the time to get the worst sunburn. But even afternoon, just right afternoon here, when you're in late spring, summer, early fall, um, you're getting a lot of radiation coming in from the sun, even when it's not at its peak. And as long as the amount coming in is more than the infrared radiative loss, that part going out, it will keep warming up. Okay. So that's why it might be 3, 4, even 5 o'clock in the summer before you reach the high. There's still enough radiation coming in from the sun to overwhelm to be greater than the amount of radiative loss out to space of infrared or long wave radiation. So it's usually sometime after solar noon. And solar noon again is just it's not necessarily noon, it's when the sun is highest in the sky, the maximum solar altitude. When outgoing energy exceeds incoming energy, temperature drops. Thus, the lowest temperatures are usually recorded just after sunrise, not before. Students a lot of times will miss that. It just seems logical, right? I mean, yeah, once the sun comes up, it warms up. Well, it starts to cool off more slowly if it's clear, but it takes a little while for there to be enough sun to the solar radiation to exceed the amount of infrared radiative loss. So it's some amount of time, half hour, 40 minutes, something like that, after sunrise before you reach low temperature, most of the time. So this next slide, and this kind of bounce to here, is all about radiation balance and seasonal temperature change. In mid-latitudes, the warmest time of day or warmest time of year lags after the summer solstice, just as daily highs are after solar noon. That would be July in Oregon. In the mid latitudes, the coldest time of the year, typically January in Oregon, lags after the winter solstice, just as daily lows are after sunrise. Now, on any given year, it isn't necessarily January, the coldest month. Sometimes it's December. And what happens is it isn't just about radiation, it's also about where the air masses are coming from. If we get some really cold continental air masses in December, they can bring a temperature down, and that's our coldest month. So it isn't just the radiative process, especially in the case of the wintertime. In most tropical areas, the warmest month is determined by the interaction between insolation and cloud cover. In areas of seasonally abundant precipitation, the warmest month can be just before the big rains begin. Okay, and I'm not going to talk so much about the last part of that phrase there, but let's look at the next slide in a minute here. How come? Let's look at this. Oh, that's right. You can't see this, can you? All right. So I'm gonna make a comment on this, and then this should help you when you have that PowerPoint slide. Um, the PowerPoint slide, when you click on this, it shows you a graph of Mexico City. Here's the thing to remember: Mexico City. It's you might want to jot this down, just kind of just understand this a little better. The sun goes directly overhead of Mexico City. Mexico City is 19 degrees north. So May, the sun goes directly overhead, and then it's actually a little north of Mexico City in the middle of the day, as it hits the Tropic of Cancer eventually, and then I think it's early August. It comes back overhead again. So in the case of Mexico City, you would think, given that from say sometime in May through August, the sun is pretty much directly overhead, that maybe it ought to peak about August or so, or maybe even a little later, kind of like our latitude. Not the case because it rains. It starts raining early, and you get the cloudiness, the rainfall, and the wet ground. And all of that reduces the heat that we sense in the atmosphere. It takes a lot of solar radiation to evaporate water, and it takes a lot of solar radiation to get through clouds. And when it's raining, obviously you have significant clouds and so on. So Mexico City is actually its warmest time of the year is March and April. And then as the rains begin, it cools off. So by the time you get to May, usually it's already cooling off, even though the sun just barely has made it straight up in the sky at that point. Bangalore, India, same pattern. It's a monsoon climate. Big rains come, cool it off. Same kind of concept.